Hello everyone and welcome back to this third session of week 1 on microservices development using Java. So now let's focus on the Java ecosystem for creating microservices application. So in order to develop microservices, any programming language and its associated frameworks or libraries can be used. However, Java is one of the most popular programming languages which is currently used by many software companies around the world for writing microservices application. And in terms of popularity, Java really ranks on the top along with the other popular languages as well, like maybe .NET and Python. So within Java, since as you guys know that Java is a language, but within Java we have a few framework, and one of the leading framework is the Spring framework, which is popular and trusted solution for implementing enterprise application. There are many projects within the Spring framework, with each project addressing a particular aspect of application development. And for microservices development, we generally use the Spring Boot and Spring Cloud extensively. So before we go any further, we have to understand what are the key benefits or advantages of using the Spring for microservice development. As we know that Java is a language, but Spring is a framework which helps us to create microservice application. So before we go any further, it's also important that you understand what is the difference between a language, a framework and a library, right? So I'll just give you a very quick recap of that. So language is nothing but the broader sense, the larger picture or the larger platform which allows you to create something. So it gives you all the syntax, semantics, the runtime, libraries, and the means to deploy the application, all that stuff. So language is anything like Java, .NET or JavaScript. So all these are nothing but your programming languages. So wherein they give you specific syntax by which you can communicate with the computer in order to perform a particular task. That within each of these particular languages, you have something called as the frameworks. So what is framework is nothing but they basically are a few patterns and technologies which are implemented in that particular language, which gives you some solutions out of the box. So say for example, if you take Spring for example, if you just want to write web applications with minimal code and where you want to focus more on your business logic rather than just the setup of your application, so those kind of scenarios is where you use the framework, wherein they give you a pattern to follow. They have certain tried and tested ways of doing application architecture and implementation. So what you do is you just use that particular framework and follow the pattern which is recommended by the authors of that framework in order to build your application. And finally, we have something also called as library. So library are nothing but the small utilities or tools which helps you to do a certain feature. So say for example, I could have a library that just converts Word to doc, or maybe a library which converts my Word document into a PDF document, something like that. So library is basically not a framework. It's not as large as a framework wherein it gives you patterns and solution for the entire application, but rather it is very narrow and specific for a particular feature or use case. Okay, so we have a tons of libraries and also tons of framework. So within Java's ecosystem, Spring is a very popular framework which is used for writing enterprise application. And even for microservices, we have the Spring Cloud, which is used extensively for writing microservices. So the following are the key benefits of using Spring for microservice development. So first thing is it's very easy to set up, configure and build microservices using starter projects. In the next session, we will be actually creating our own microservices using Spring. So you will actually see this for yourself, like how easy it is to create a very simple application using Spring. Literally you don't have to write a lot of code for that. Next is the security, configuration management and other capabilities are built in. Since it is a framework, there are a lot of design patterns and recommendations which are given by the Spring team itself. So the advantage of that is you don't really have to bother about a lot of such cross-cutting concerns and management as well. It also supports auto configuration where possible and avoids XML configuration. So the beauty of this is whenever you create any new class or any new application, so it will try to see if this can be auto configured. So I'll give you one simple example. When you create a simple starter project from Spring, so it automatically downloads all the Maven dependencies for you in the background. It has its own built-in server and all that stuff. So when you just run the application, all that things comes into the play and your application starts up. So the beauty of this is you don't really have to write a ton of XML configuration, other stuff, which used to be the case in the previous in the pre-Spring era, where you have to write all these things by yourself. Next is the deployment and monitoring of microservices are easy with embedded server. So what Spring does is Spring has this built-in Tomcat and Jetty servers embedded. Whenever you kind of write your application and you want to deploy your application, so using those embedded server, the application can be deployed and started quickly. So even this we'll be seeing in the next session, where you can see for yourself how without doing any server configuration we can still run our Spring microservice application quickly. And finally, Spring has a wide open community of Spring developers. So the advantage of this is whenever you run into any issues, or you want certain features, or you're not able to understand how to do a particular scenario, you can very easily look up that question either in forums like Stack Overflow, where you can get solutions. And even if you have any active questions which are not yet answered, there will be people who can easily answer that for you, because the number of developers who are using Spring is quite huge. So Spring ecosystem is quite large. Just like Java, even Spring is quite big because it is a framework. It operates on multiple layers. So, and the Spring framework is basically just an overarching term under which there are these many projects, and also there are new projects coming up every time. So what we have done over here is we have just conceptually divided or separated each of these Spring projects based on the capabilities or based on the layer on which they operate. So on a high level, you can say that Spring can be divided into three part. So one is the Spring IO platform, which is the web layer. The second is the Spring Boot part, which is the common layer. And the third is the Spring XD part, which is basically nothing but operating on the service layer and data layer. Okay. So what each of these project does, and what is the implication of that, probably you can just look at it quickly, based on each of the project does. But all you need to understand is each of these projects are only concerned with a particular aspect in that particular stack. So say for example, if I take Spring Test is only concerned with writing the testing your application and nothing else. So if you take Spring Session is only bothered with maintaining the session and all that stuff. So whenever you want a particular functionality, you have to use that particular Spring project in your application and do it. And for our case, since you are going to write microservices, which is going to be hosted in cloud, we will be utilizing Spring Boot and Spring Cloud to a greater extent. Okay, so let's just quickly run through what are the various parts of what are the various projects of Spring and how they work. So at a high level, right, if you just see, as I said, it can be divided into three parts. So what we'll do is we'll just quickly check just see what are each of these projects and what it does. So first, just let's quickly get into Spring Web Services on the left hand side that you see. So Spring Web Services is nothing but it just helps you to build a contract-based, SOAP-based web services. So what happens is as we saw earlier, you have something called a SOA architecture, right? So wherein what was a SOA architecture is, as I said, you have two entities wherein they establish a contract between each of them, where the client kind of request a particular request in a particular format, and the server will going to respond them in a particular format. So if you want to kind of build a contract-based web services, so that is where when you use the Spring Web Services. So Spring Web Services is similar to the SOA architecture, where you have the SOAP-based WSDL and all that stuff coming into play. So where this is basically used is whenever you have to write any domain-specific languages, or you're dealing with any of the traditional services where the SOA architecture is still into play, or contract-based API is still into play, and that is the place where you use the Spring Web Services. Next, you have something called as the Spring Social. So as the name eliminates, as the name says, it is nothing but just a plugin or the tool where you can kind of allow the user to interface with Facebook, LinkedIn and all those social media sites, and in order to create new account for your application. So you people would have seen scenarios where you go to a particular application, and instead of creating a new login, you can directly link your existing Google or Facebook login to that particular application, right? right? And it creates an account for you. So in those kind of scenarios where you have to kind of integrate the social applications with your with your application, you use the Spring Social. So the next we can talk about the Spring for Android. So what, as the name suggests, this is basically for developing native Android applications. So what happens is, like, if you have to develop any native mobile Android app based application using the Spring framework, so this project helps you to do that. Next, you would have seen that there's a project called 8OAS, Spring 8OAS. So what is that? Is basically, like, 8OAS is nothing but it's a principle. So what happens is, like, on a high level, right, what happens is you can develop REST services which can return metadata about other discoverable services or representation. Okay, so on a high level, right, what we can say is, like, it doesn't really have dependencies, and it is really easy to introduce and pull things out of your project. Okay, the next is kind of Spring Mobile. So Spring Mobile helps you to, as the name suggests, mobile applications or mobile friendly pages. So if it detects that you are accessing the application from mobile, then it can serve you the pages which are optimized for the mobile platform. Okay, the next is the Spring Web Flow. What is the web flow is, like, it allows you to kind of separate or split the data between multiple screens for easy navigation. Assume that you are kind of developing a bank application, and you want to create a bank registration form. So you would have noticed that the form gets split into multiple screens. So where in the first screen you have introduction, second screen you have maybe your contact details, third screen you have your income details, so on and so forth, right? So those kind of scenarios where you want to kind of split your data into multiple screens, make the navigation easy and all that stuff. So that is where the Spring Web Flow will come into picture. And finally, we have something called the Spring Security at the bottom. So Spring Security, basically, if you see, is kind of the core to all this, because it is something like that makes your application secure, and it kind of controls, like, who can interact with your application, and what is the level of authentication and authorization. So Spring Security is basically, see, the other projects can be optional in your application, like depending on what you do, but Spring Security is definitely not optional, because it is something that you have to include as part of any application which you are developing. And Spring Security also has its own database schema, and that is kind of the use of Spring Security. So wherein, like, you write the logic for all the authentication and authorization. And after that, you see in the center there is something called as the Spring Boot. So Spring Boot is nothing but they all leverage again the Spring framework, and these are some of the common projects which we have, which is a core container, messaging, AOP, which is aspect oriented programming, Spring Web, data access, test. So using all this, the use of this is they all help you to kind of, like, say develop the, like, the core application or the common modules of your project. So the next part you see on the right is the service layer projects. So what happens in the service layer is, like, whenever you want to, like, write services and integrate services, so that is where, like, these Spring Cloud and Spring integration come into picture. So, and then finally we see something called as the data layer. So what is the data layer is, like, these are predominantly into data handling and manipulation. So whenever you want to handle the data and manipulate the data, that is where, like, you use the projects like Spring Batch, Spring Data, Spring LDAP, and AMQP. Okay, so that was pretty much about, like, the Spring ecosystem. So this was just a high level understanding about what a Spring ecosystem is all about. If you are new to Spring and also new to Java, I would highly recommend that you just spend a few time after this session understanding about what is Java and why Spring came into picture, what are the various projects of Spring. So in this course, as much as possible, we will be covering each of these projects which is applicable to our microservice application while building the banking application. And I'll be explaining and making you understand what are the various parts of Spring. But humanly, it is not possible to make you understand all the parts of Spring ecosystem because it's quite big. Hence, I personally advise you that, you also kind of explore this in your part-time, like whenever you get some free time, just go ahead and, just go to the Spring website and try to understand what each of these parts are doing at the end of this course. And that's pretty much about the Java ecosystem for microservices. And before we go further, it's also important to understand, like, what is the runtime, how the runtime of Spring framework looks. So what is the meaning of runtime is whenever, like, I kind of create, like, run my application. So what happens is in my JVM or in my main memory, there is something like, kind of a container created under which all these things run, right? So what happens is for my application to run, there are also a ton of other components which has to run in order to ensure that, my application gets executed. So for this, this is how a sample Spring framework runtime looks like, where you have a ton of other components which will be running in the main memory. So where you can see that you have this data access integration component, under which you have this JDBC, ORM, OXM, JMS transaction. So basically what it does is, whenever you want to interact with data or manipulate data, that's where you use this data access and integration comes into play. The next, you have the web layer, where you have this WebSocket, servlet, web portlet. So basically whenever you have any incoming request and other stuff which is coming from the web application, so these guys ensure that all those requests are handled properly. Then you have this common layer of AOP, aspects, instrumentation, messaging, which is kind of the common layer which runs across. Then you have the core container. The core container consists of the beans, cores, context, and spell. Spell is nothing but the Spring expression languages. And finally, you have the testing framework. So the core container is nothing but, as the name suggests, it is a core, and it is it provides kind of the implementation of the features, like Spring provides us something called as inversion of control, dependency injections, and singleton design, and so on. So to implement all that, we require this core container. And this bean is nothing but the factory design pattern, which using the bean factory, by which we can create multiple beans, and so on and so forth. So the focus of this course is really not the Spring, so I'm not going to really go much deep into Spring any longer. But this was just to ensure to make you understand that you at least have a basic understanding of Spring before we dive into creating the microservices. So as I said, I highly recommend that you guys just go back and go to the official Spring website, spring.io, and just understand what this Spring is all about, in case you're not aware of Spring. And also, if you're not aware about Java, you're not too much conversant with Java, I would recommend that you at least have a basic knowledge of Java, so that it helps you to pick up this course as we go ahead. But don't worry, we'll be covering most basic part of the concepts as required, so in order to make it easy for you. So with that said, we have come to the end of this session. But before we wrap up, I just wanted to quickly summarize why we are using Spring and what is the advantage of using Spring and all that stuff, so that the concepts really stay in your mind. So just remember that we have seen what is the advantage of microservices, right? So we saw that microservices, it's easy for us to create independent services. Each of them can be scaled easily and all that stuff, right? So then for writing microservices, we have a ton of different languages. So normally Java is usually preferred in the enterprise. And within Java, a Spring framework is normally recommended for writing enterprise application. So what are the features of Spring? One is it is lightweight, because the size of the Spring is very small, and it is very easy. And it's very lightweight, and the bottleneck or the runtime is quite smooth. The second thing is it has something called as inversion of control. Okay, so what happens is Spring framework gives you kind of a loose coupling. So what happens is each object, as you saw, right, Spring framework has multiple independent projects which can be used for different purposes. So what happens is each of these objects can give its own dependencies instead of looking for dependent objects. So you can just pick and choose different projects as you want, pick and choose different modules as you want. So this concept is called as inversion of control, wherein you're just loosely coupling your entire framework. Next is something, as you can see even in the runtime over here, is called AOP, or aspect oriented programming. So what happens is in the aspect oriented programming, we just separate our application business logic from the system services. So that is the core concept of aspect oriented programming. So what happens is all the business logic, you just separate it out into a different services, and any services which are only concerned with the system, runtime, keep up, and your application, that you separate it out. So the beauty is you can evolve both of these services parallelly, independent, without tightly depending on each other. That is called as aspect oriented programming. The next is Spring framework also creates and manages the lifecycle and configuration of the application object. So it provides a container or a runtime where all your application objects and beans would be managed by itself, so that it reduces an overhead for you. The next is Spring framework also provides a MVC web application framework, wherein using that MVC framework, you can develop web application out of the box. So Spring gives you an end-to-end solution to create application. And also finally, the Spring also gives you means to manage transaction. So since it gives you a lot of abstraction layers, it is very easy for us to manage transactions. And also, like, even in case of JDBC and other kind of data integrations, we can also handle the error effectively. So that these are kind of some of the few advantages of using, like, Spring. So with that said, we have just reached to the end of this third session, and in the next session we will then start with the creation of microservices. Thank you.